hurry up, we have to operate on these equations. Stat, clear, boom. Oh. Okay, thank you for that. Can you do yay math with that type of phrase? Or you don't want to do it? You don't want to do it.
I don't care.
Do it right now. Go ahead, why not?
Yay!
I can't believe forgot about that part. Okay, if I can get my thumb in. Ooh. Not safe for surgery. Doctor, are you? I know. Okay, let's begin the discussion talking about relations. Okay, relations are basically relating any two, for the time being. I would take that off here. Relating two pieces of information. Okay, so you see at the top of your page, it has, like, let's say for cats, and it has average life and max life. Okay. Can anyone guess what the average life of a kitty cat is?
12 years.
It is 12. It is 12.
Oh, wow.
That's good. And what is the maximum life of a kitty?
18.
25, 28, actually.
28.
Whoa!
Wow.
I'm like a cat junior.
28, yeah. Okay, so basically we're relating two pieces of information. For cats, the average life is this, and the maximum life is that. Okay, and we can relate other pieces of information. Let's say X and Y. Two pieces of information. Okay, so you can see at the graph, at the bottom of your page, you have 1 point marked. I think it's 2, 3. Is that correct?
Yes.
All right, and there's 3 more points there. Try to re-familiarize yourself with the graph. It's stuff that you all should have seen by now, hopefully. Keeping in mind that X is to the left and right, and Y is up and down. See if you can label those 3 points.
Where?
On the bottom of the graph. Yeah, you see 3 points in 3 different quadrants.
Label it?
Yeah.
Okay.
Right. Just label the points. Yeah. First quadrant, 2, 3. I'm going to do some equation operation. So this is the first quadrant. What's the point that you guys have in the second quadrant?
Negative 5, 4.
Negative 5, 4 is right. Negative 5, 4. Those of you without packets still, you can feel free to look at your neighbors. And you'll get you those momentarily. Negative 5, 4. What about down here?
Negative 7, negative
Negative
8.
I'm feeling negative 3, right? Negative 7, negative 3. That's right. Negative 7, negative 3, meaning we went left 7 and then down 3. And then finally, last quadrant over here.
6, negative
6, negative 1.
Negative 3.
6, negative 3.
I wrote that.
Bless your soul.
Thank you.
Welcome, if it can be. Okay, so that's a reacquainting with graph. Again, going left to right, and then going up or down. Okay, please flip the page to the next side. Okay, and so now we're going to define what the term relation is. Okay, relation is a set of ordered pairs. Set of ordered pairs. Okay, so let's come up with a set. I'll come up with 1, maybe 1, 2. You give me another ordered pair?
3, 4.
3, 4, why not?
17 and 31.
Kind of harder to graph, but can we be maybe in the neighborhood?
0 and 1.
0, 1. Okay. 0 and 1.
It can be any two numbers.
Yeah, any two numbers.
In
Okay.
the world.
Yeah. Let's talk about now what domain and range mean. Okay? It was actually a cool department chair sitting in for half of the lesson, or whatever, a quarter. Did that make you nervous or anyone?
Yeah.
Made you nervous?
At first, then like.
At first, don't be nervous. It's okay.
He's a doctor.
He's a doctor too. That's cool. Oh yeah, what's the name of my character?
MatheMEDIC.
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 MatheMEDIC. I'm going to operate on him. How? And then they like wake up with like math equations on their body like this. Funny.
I had a heart problem.
It's like, he forgot the negative on me. You know? That'd be cool. Anyway, in my world. All right. And I always put this on my finger, it's funny too. So domain. I know you see the word domain there, and it has a definition. All right, the best way I can say it, it's all possible x values. The beginning is a lot of definition stuff, and it's kind of rote, but once we get to later in the page, you're going to see why it's going to be necessary. So can we do the domain for this, bless you, this particular set? What are all possible x's, yeah?
0, 1, 2, 3. 1, 3.
1, 3, and?
0.
Yeah, that's right, so we can go ahead and put that in, good job. 0, 1, and 3. Order doesn't matter for domain, okay? Range subsequently, what do you think it is? All possible?
Y.
All pos y vowels. All right. And what are the possible y values in this case?
2, 3.
2, 4, and 1. Okay? And by the way, if there's another point in here, let's go ahead and add, let's say, 1, 4. Add that point to the set, please. And now does the obviously I'm not a speech doctor. Does the 1 have to be rewritten?
I don't know.
No.
It doesn't.
No.
Is 1 possible for x here?
Yeah.
Yes. So 1 is listed as a possible x value. And 4 is already listed as well, so we don't have to relist that as well. Okay. Let's define, we're going to get into discrete and continuous in a second. Let's define function. All right, I want to ask you 2 questions. First question, raise your hand if you've heard the word function before, somewhat familiar. Okay, most everyone. Raise your hand if you can comfortably define what it means. Okay, less people, you want to try?
A special type of relation in which each element of the domain is paired with exactly one element from the range.
Okay, don't be afraid to be wrong or sound like yourself. Oh, is that what it is?
What? No.
You're not? Okay, good.
What's the question? What
problem was she had no
I thought
idea
you were
what it
afraid to be
was.
wrong, so you were reading it off the paper. You know what I
Oh
mean?
no, that's how I was defining.
That's how you define it yourself? Okay, well, you're right, you're right. The way I would define it, anyone else want to give it a try maybe in something less formalized? Okay,
I mean,
where's Cornelius?
Cornelius.
Yeah. Where's Bob, right? You want to try?
It's where an x is paired with a y.
An x is paired with a y, and can x repeat or not?
No.
Yes.
Oh, yes.
You're right.
Okay,
Yes,
sure.
you're right. Okay. So it's basically pairs when x cannot repeat.
What do you mean by cannot repeat?
For example, here, I'm glad you asked. Is this particular relation a function?
No.
It's not, because does x repeat itself? 1, 2, 3, 4, 0, 1, 1, 4. The 1 repeats, 1, 2, and 1, 4.
Oh.
So this is not a function. Okay. We're going to actually do this in a more graphical way too, by graphing it. If you can pick, or just maybe make a quick graph. Doesn't have to be fancy schmancy. Nice catch. Doesn't have to be fancy. We can graph these 4 points. I'm feeling a 1, 2. Let's see if we got green here. And then we have 3, 4, 2, 3, 1, 2, 3, 4. And then we have 0, 1 here. And then we have 1, 4. Oh, I did 1, 4, 1, 2, 1, 4. There it is. There we go. Okay.
Oh yeah, and
Yes.
isn't it like the pencil thing where you like move pencil across to see if
Vertical line, you're right. It's called the vertical line test. If a vertical line, any vertical line, can hit your graph twice, it's not a function. And so we see here at this particular, oh my god, I gotta see this. What happened?
Dude, it took so long. They forgot I was sitting there.
They forgot you were sitting.
Yeah, I was just waiting.
Give them to people. We're actually filming right now. Good job. Thank you. Let's give them a hand, you guys. Really.
Yay, Cornelius!
Went to the office and got copies for people who need copies. It was my mistake. I didn't make enough. I didn't make enough. I made enough.
Cornelius!
What does it say behind you? You were gone.
Here?
Oh, come on.
What? Yeah. The next cannot
that's all I
repeat.
know.
The next.
Right here.
All right. Wait.
Can you repeat the vertical line test?
Yeah, we'll repeat the vertical line test. It's the last thing you say because it's an important test. It's actually pretty easy. I think we're good. Good job. Thank you. Okay, thanks. Oh, yeah, I can use one. Why not?
Oh, and here's your marker.
Oh,
He's talking about
yeah.
the marker.
You even bought the marker. Good job. Let's look at this. Oh, man. Yeah, we are. Well, just for you. You're immortalized. Let's talk about vertical line test, all right? Okay, we got to get through it. Vertical line test goes like this. If the vertical line hits more than once, then
So if it
it's
hits more than 2 points.
more than once.
More than 1 point.
And then it's automatically not a function. All right? It's basically the
And
idea.
this is only for X?
Yes.
What if it can Y? What if it's a horizontal?
Y can repeat, it's okay. Horizontal line, you could still be a function.
Okay.
All right. Let's go ahead. We're at the example 1, section, part
Oh,
A.
yeah.
1, 5, 2, 3, 3, 7, and 4, 7. Yeah.
Oh.
Right, 9 is not included. So what is the domain here? All possible x values are?
1, 2, 3.
1, 2, 3, and 4. What's the range?
5, 3, 7.
5, 3, and 7. And that's it, right?
Yeah.
We don't have to repeat the 7 because 7 is already included. Okay, so we can go like this. Domain 1, 2, 3, 4. Range 5, 3, and 7. Is this a function?
Yeah.
Yeah.
Yes, it is a function. Does x repeat?
No.
No, it does not.
Only Y does.
Right? And the next one you see, 0.1 and 10. 0.1, 0.1, 0.1, and 20. Now, is this a function?
No.
Oh.
No, not a function. Very good. Okay. But the domain would be all your x values in the list, and range is y, please.
If you write all the domains and then you don't, like, where there's 2 7s but we only write the 7 once, but how would you know if it repeats if you don't write ones that repeat?
Whether or not it repeats is not important.
What about for,
Same for domain.
oh,
It's just all, what's possible.
oh,
Okay. Here's the lion's share of the lesson, and I'll be really pleased if we can get this by today, because it's not so visibly clear at the very beginning. All right, it's the graph that you see that has that little curve going with it. Okay, I'll try to replicate it here.
A parabola or a
It's not a parabola. It's a good guess. The parabola is on part D.
No, this is B.
Yeah, this is B.
Wait.
Okay. Looking at this, we're looking at part B. Now, first question, and we could do it with the vertical line test. Is this a function?
Yes.
Yes.
Yes. Any questions about why? Please feel free. Vertical line. If a vertical line hits once, it's okay. If a vertical line hits twice, it's not. So yes, this is indeed a function. Please.
What if it's just straight down? Wouldn't the line be?
If a line is straight, then that's not a function. But this is curved. It's like slanted, just creates a function. Now, domain. All possible x values.
We don't know.
Let's talk about it. Let's say, for example, can x be 0?
Yeah.
Oh wait.
Where is x 0?
On the x-axis.
Here?
No.
No, good job. Here?
Yeah.
Here, x is 0, indeed. What is this point?
0.
It's on your graph.
5.
0, negative 4, I'm feeling 0, negative 4, right? So x can be 0. If we wanted to draw a chart, x and y, 0, negative 4. So 0 is included in the domain. Okay. What about 1? Can x be 1, going bigger?
Yes.
Maybe like right here, right? X is 1 there.
But what if we don't have actual numbers on a graph?
We could look at the graph and see.
No, if it's like a completely blank graph.
Oh yeah, you need something. We're only looking at the green thing. You're right.
It looks like it's 1, 1.
1, 1.
Where?
That's like you're 1, -5.
Oh.
1, -5. My curve should be more over here, actually.
Yeah.
So sorry about that. Let me fix that real quick. Can't believe they forgot you were there.
I know, and I was sitting right in front of her.
Was she like apologetic or something?
No, but I
No.
like examined her facial expressions. Like I knew what she was doing on her computer. Like I could
Yeah.
there was like a formula.
One
I
negative
am.
6.
What?
This is 1, -5, isn't it?
Solitaire.
-6.
Wait, so she got the papers from you and didn't go in common and just sat at the back at her desk?
I don't know.
Isn't it -6?
No, it went 5 down. Look closely.
Well, because it says -5 and then it's.
-5 and -1.
Oh, this one's one.
Yeah, okay. So x could be negative, x could be 1, can x be 2, 3 or 4, maybe 3 here, isn't it? X is 3 here.
3.
Can x get incredibly large if it wanted to?
No.
Yeah.
Yeah.
I think so.
Yeah.
Is it all
Can.
real numbers?
Isn't x, yes. Isn't x a measure of left to right? So what I want you guys to do is look at this graph and say to yourself, okay, I'm only going to think in terms of left to right. Am I going to the right?
Yeah.
I am. Officially, I see it and you see it. I am going up to. I know that. But I'm not thinking about that for a domain. I'm thinking about whether I'm going to the right. And does x have to stop ever?
No.
No. So the domain is what?
All real numbers.
All real numbers.
Then how do you find the range?
Let's do the same thing for y. Good question.
All real numbers.
All real numbers is for a graph that's like that too.
Yeah. Yeah.
Yeah, it's all real numbers too.
It is going to be all real numbers.
Everyone except for the one.
Here, this is 3, 0. So we conclude that y can be 0. Now, can y get bigger? Meaning, does this graph go up?
Yep.
Yeah.
It does. Does this graph officially go down as well?
Yeah.
Yeah.
So what's the range?
All real
All real numbers
Don't
as
they
well.
all unless they're...
It depends. Depends on the graphs. Okay.
I don't
Next
know
one won't
why
be.
is it all
Like
real
parabola,
numbers?
like where you can't have all real numbers.
Right. You'll see. You'll see. No, I'll tell you. I'll tell you. What's your name? Princess.
Bob.
Diana.
Princess
No.
Bob.
Princess Bobina.
Babalina.
Yeah.
Babalina.
Princess Marley. How about that? There you go.
Okay.
So the reason why it's all real numbers is that isn't the graph going down? Y is getting negative, negative, and it got a little bigger, and then getting smaller and smaller and smaller again.
Yeah.
So y can be incredibly small. Here.
But
And y can be incredibly big. So y can be anything. Name any point for y, and I'll tell you where it is on the graph. Negative 100 around here. 100 maybe up here. Anything. Y can be anything. Let's do another example, right? You see the one that looks like the,
it can't be on that side.
what,
Yeah.
over here?
Negative like that over there.
It's
Oh, but that's x.
That's x. And it was going to the left, officially. It was going to the left. Do it in comparison with this. 1, 2, 3 here, and then we have the green graph that looks like this.
Not a function.
Good job. Can you explain why this is not a function?
Because it doesn't pass the vertical.
Doesn't pass the vertical line test. Very good. So you can go ahead and put NF for not a function, because if we hit twice, fails the vertical line test. Okay. Now let's do domain and range for this. This will be harder to do. Domain and range for this guy.
So we should just write next to it not a function?
Not a function. Immediately you could tell right away that's not a function. Okay, now, domain. Range. Now, let's start for 0 for x. Where is x 0, if at all? Yes.
When it's on.
Here?
Yeah.
Right. What's this point?
0,
3.
3.
0, 3,
Wait.
correct. Please.
That doesn't hit, that hits the Y.
It hits the y-axis, but this point is when x is 0. Right?
Oh, okay.
Right. So x can be 0 if it wanted to. Now, thinking in terms of left to right, can x go to the right, meaning getting bigger? Yeah, it does here, right? Does it also here?
Yeah.
Yes. X is getting very large. So X can start at 0 and get very big. Can this graph go to the left, meaning X getting small?
No.
No. So what is the domain?
Anything.
All positive numbers.
Oh, so how do you say that mathematically? All positive numbers, including
X
0,
all
is
whole numbers.
Greater than 0.
All whole
All
numbers.
whole numbers.
Or
Or
equal
equal
to.
to 0.
Sorry.
It is all whole numbers. Very good. And everything between, like 0.1, 0.2. So greater than or equal to 0. Okay? In other words, if I wanted to graph the point -1 for x, I couldn't do it. Bless you.
Thank you.
I couldn't do it here because there is no -1 for the green graph. Now let's talk about y. Can y be 0?
No.
Look
Yeah.
closely.
Wait, yeah.
Yeah, yeah. Where is y 0?
That, like,
It's like
There.
Right here.
Like 11.
9.
10 or 9.
9.
So this is 9, 0. Yes. Thinking in terms of y as an up and down. Can we get very large? Does this graph go up? Yes,
Yeah.
y can be 1, 2, 3, 4, 5, 6. We're going up and up and up. So y can get very large if we wanted it to. On this green graph, can y get very small as well?
Yeah. So
Yes.
it's all real numbers.
So indeed, it's all real numbers. Y is getting small because we have this thing going. So y is the set of all real numbers again. All right. Good job. Okay, next, let's do, I think we're pretty good so far. Let's do part B. Part B here. We have y equals 2x minus 1. Does anyone know what type of graph this is? Yes.
Linear.
going down linear.
It's a linear. What's the first 4 letters of the word linear?
Line.
It's a line. It's a line. L-I-N-E. L-I-N-E. You answered the question. Very good. So it's linear. If we wanted to graph this, don't worry if you don't remember the y equals mx plus b formula. We will go over it. Okay? But in case you don't remember, we start down 1 over here, and then we do a slope
Up
of up 2 over 1. So we can do that.
Would it
1,
be up
2.
2 minus
Can we
1?
please go
No,
over that?
'cause it's-
next
We will.
time?
That's actually next section.
What?
So for the time being, just go with me. Just let's do the graph together. 3 questions. We'll do function, domain, and range, and then we're done.
Function.
Is this a function?
Yes.
Yes. Yes. Domain.
All,
Yes.
All possible values of x.
all real
All real numbers.
All real numbers. X could be 0, 1, 2, 3, 4, 5 going up and up, and -1, -2, -3 all the way down.
Range the same.
Range, y can be 0 going up and going down.
All real numbers.
Also, all real numbers. Okay, good job. Good job, you guys. Do you have an applause feature or something? My surgery is done.
Is there home?
Yeah. But I'm going to shorten the homework because we didn't cover everything, so it's okay. Woo! Does this thing fly?
Oh, please.
Oh, don't worry, I'll do it up.
Should make a balloon out of it.
I covered the wrong bit.
I was like,
Yay, math.